Hey folks, this is Dave Price from Vision's Virtual Math and Science Center. We're undertaking our second PBL project-based learning experiment today. It's a hydroelectric generator. Here I'm filling the dam, actually a bucket, and we're going to fill it to the top. Then we're going to open this valve right here, and the height of this water, which is about 12 feet or so, goes all the way down to the little hydroelectric generator device there, which is right there. The water is going to flow through there, spin that turbine wheel, then it's connected to a couple of leads to my multimeter to determine what the amps and the volts are, and we'll turn that, and in our calculations we'll turn that into power. So this is our next experiment, and we're getting ready to open the valve and let it rip, and we'll go down below and see what's going on as soon as this bucket gets filled. And we're getting there. Let's open the valve and see what happens. So there we are at the top, coming all the way down. That's like the penstock on a real hydro plant. It's just a half-inch hose here for our purposes. And then we're coming here into the little device, the little spinning turbine. And you can't really see the blades spinning because it's spinning so fast, but they are turning. And I guess that's why we're making electricity, because we're actually spinning a generator. So pretty cool setup. And there it is, being squirted out down there, and it's coming from this bucket up here, obviously, so the amount of electricity is directly proportional to the height of the water supply, which is called static head in the engineering world, and we're going to try to calculate that and see if that is in fact true. Here's a ground level shot of the setup with the discharge there. It's coming out pretty good. It's a clear plastic little hydroelectric generator device, and what's pretty cool about it is that you can see the little rotor spinning in it. I'll show you that in a minute. There you can see its top view of it spinning. Under this setup, it's making, you can see it's DC volts, 13 volts, and about 44, 45 milliamps, 44.5 milliamps for this case. Okay, now we're set up on a ladder. I want to lower the height and see if the voltage and the amperage, the current and the volts are lower, so we're now back into the hydroelectric generator there. So first of all, the water's pouring out a lot slower, and the vanes are not even turning. Now we got it going. Let's see what happens here. I'm not refilling the bucket right now, so the level is continuing to drop, and this thing is slowing down for sure. Hey guys, it's Dave Price. I wanted to add a footnote to our video on the Hydroelectric Project. We had the amp and volt reading with the bucket on the deck at the top, but not on the ladder, and so I have those readings. I forgot to add them to the video. 7.7 volts and 17.4 milliamps is what we obtained on average. Those are both lower than with the bucket on the deck, which is to be expected. So we will analyze both sets of data and check it against the equation that's typically used to determine the relationship between height and power output for a hydroelectric plant. So I wanted to add that to the end of this video. So have a good day.